All right, here's our next lesson, adding polynomial word problems. So the key with word problems is drawing pictures. They don't have to be great pictures, but you got to draw a picture. So let's just work through a couple word problems and you'll see what I'm talking about. So the first one here, if the length of a rectangle in terms of x is 3x squared plus 7x plus 9 and its width is 3x plus 6, what's the perimeter of this rectangle? Well, the first thing you need to realize is the perimeter equals all sides added up. So I'm going to draw a rectangle just right in the middle of this space here. Now the length of it is represented by 3x squared plus 7x plus 9. Well, if you know anything about rectangles, the length on one side is equal to the length on the other side. So the other side we can also write as 3x squared plus 7x plus 9. Now the width is 3x plus 6, and if it's the width on one side, it's also the width on the other side. Now if you want to just solve this symbolically, you can go ahead and add up all the things that are the same, that collect like terms. So 3x squared plus 3x squared, now we're at 6, and there's no other x squareds. So 6x squared. Now let's go to just the x values. So 7x is 14, plus 3 more is 17, plus 3 more is 20x. And the last one, 9 plus 9 is 18, 18 plus 6 more is 24, and 24 plus that last 6 is 30. So that would be the perimeter that we've added up. Now if you're using your algebra tiles at home, you can go ahead and you can draw these actually. So if we're saying that unshaded is going to be positive and shaded in is going to be negative today. So 3x squared looks like this, plus 7x. 1, 2, 3, 4, 5, 6, 7, and 9. We've got 9 there. Okay, and then 3x over here, 1, 2, 3, and 6. And 3x over here, and 6. 3x squared plus 7x, 2, 3, 4, 5, 6, 7, and 9. Now if we just count up what we have, so we have 1, 2, 3, 4, 5, 6, 6x squared. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, look, there's just 20 x's. And then if you count up all the single digits, that's your 30. Here's another perimeter question. Farmer wants to put a rectangular fence around his field. Write an expression for the perimeter of the field. Well, if it's rectangular, these sides are going to be equal. So this is also 5x plus 2, and this is also 2x minus 1. So the expression for the entire thing is going to be 5x plus 2 plus 5x plus 2 plus 2x minus 1 plus 2x minus 1. Now go ahead and collect like terms. 5x plus 5x is 10, plus 2 more is 12, plus 2 more is 14. So we have 14x. 2 plus 2 is 4, minus 1 is 3, minus another one is 2. So 14x plus 2. Now, if x is equal to 6 feet, how many feet of fencing does the farmer need? So substitute in 6 in for the x value. Okay. Now 14 times 6 is 84. And 84 plus 2 gives us 86 feet of fencing. Here's a PAT question that is very confusing on the outset, but really it's just a lot of canceling out. So we have three sets of polynomials, polynomial 1, 2, and 3, and we're having a missing polynomial that you're going to fill in with some amount of tiles. We don't really know what tiles yet, but you're going to be doing some amount of tiles. And the question is saying, if you add up all these tiles plus whatever is missing here, the result is going to be 6x. So all we're going to have left is 6x. So if we draw that out, that's a little too, I think let's make it a little bit finer. So if all we have left is 6x, so 1, 2, 3, 4, 5, 6. So let's go ahead and find our zero pairs and see what's left after canceling out. So that and that are going to cancel. This one and this one can cancel. Those two. Those two are going to cancel. Those two cancel. They make a zero pair. This one and that cancel. This one and that cancel. And those two will cancel. And that one cancels. So after eliminating all our zero pairs, what we're left with is these things, right? Well, the question is saying if we add in a couple more tiles here, they could be squares, they could be x values, they could be single digits. If we add in a couple more, what we're going to have left is these 6. Well, we only have 5 x tiles, so that means we at least need to add a 6th one there for it to exist. And we don't want these 3, so the opposite of those are shaded in x squares. Because when you do your zero pair now, that will simplify, and that simplifies to a zero pair. The last thing we need to get rid of is these 2. Well, the opposite of those are 2, unshaded, those should be unshaded ones, squares. Okay? We'll go through, and do you have this as one of your options? 3x squared plus x minus 2. Well, there it is. There's one of your options. So here you have classwork on page 30. There's just a few word problems that you need to complete.